We're going to take a look at the practical side of things. Capturing reality is one thing, but building stable, scalable pipelines around it is where most teams actually struggle. So let's tackle that topic head on. Let me welcome to the stage owner and the founder, RichPix, Barry Bassnett. Barry, join me on stage. I'll get you the clicker.
All right, thank you. Hi.
Clicker is over here. Fantastic.
Oh, thank you. Oh, great.
Very good.
Thank you.
And I'll take this away as well.
All right. Hi, everyone. It's lovely to be here again. It's a year since I was here. And I don't know about you, but I've been really busy. I hope you have too. It's been an amazing year when you look at what technology has arrived. The Gaussian splat has exploded. We've got all sorts of different ways of delivering things. Now, my business is RichPix. This is what I do. But basically, what I work in is spatial imagery. I started life as a very small photogrammetrist. But now it's expanded, and it's about what we do with a camera to share our world. Whether that's photogrammetry, or taking images to produce Gaussian splats, or tagging images, or colorizing point clouds. My thing is really what I look at the camera. That's what I look at. And I'm going to share sort of a little journey over the last year that I think has been significant to me. And I hope it's going to be significant to you, and maybe introduce you to a few subjects which maybe you didn't know. So I'm going to talk a bit about hardware first. So hardware. So I've been playing about with a new camera. It's called the Sony A9 III. And this has changed the way I think about photogrammetry. It's pushing us into areas that I've not been able to do before, because it's the first full-frame camera with what we call a global shutter. What that essentially means is I can sync flash to an 80,000th of a second. So suddenly I can do photogrammetry of a bullet passing through. Now, what does that mean to you and me? Well, photogrammetry sometimes gets into difficult situations. If I want to do photogrammetry of, say, a tunnel or a road, and I want to mount it on a vehicle, well, what we get quite often with the rolling shutter is this pixel smearing. With this, we can eliminate it. Or I might want to put it onto excuse me while I get there. So I might want to put it onto a project where things are vibrating, like an oil platform. Now, a vibrating tripod and a camera is a killer for photogrammetry, but not anymore. And there's sort of 6 things that are improving with photogrammetry with this particular camera, and I think it's the first of a whole new series of cameras that we're going to get. First is speed of capture, because now I can put this on a camera on a vehicle, and I can scan at 50 kilometers an hour with no pixel smearing at all, which might not sound too good, too interesting, but if I'm doing tunnel inspection, it's really interesting. Object movement is, the objects might be moving or vibrating. I can also shoot at 120 frames per second in RAW. Okay, now, a lot of the workflows that we've got these days use video. And the problem with video, it uses a rolling shutter. So if I move, I do get a degradation. I get 120 frames in RAW static imagery, which doesn't sound that exciting, but for me it really is, and I'm a geek, so it's that. The other issue that we get is if we want to do long-range photogrammetry, because we have to shoot through the atmosphere. And the atmosphere, like on a hot day like today, shimmers. We get a thing called scintillation. We also get scintillation from satellite imagery too. It's another story. But this negates that. We get noise reduction, and we get an increase in resolution. And that's a little bit about the hardware, which we are going to see over the next few years in photogrammetry, which is going to change the way we think about things. But on the other side of things, I spent my life, I started life as a cartographer. And what I see is all these fabulous technologies. But I see a thing called what I call the atlas problem. The atlas problem for me is about, I can put an atlas on a coffee table, or I can put a point cloud or a mesh. But it only becomes useful if I've got an index at the back so I can find what I'm looking for. And one of the problems that we have in our sector is we produce these massive point clouds, but we can't find anything. It's great to look at, it's great for familiarization, but what do we use this for? And the same applies whether it's a point cloud or a Gaussian splat. And in order for us to do things, what we really need to look at is three things, I think. Findability. How do I find Dead Beaver Creek or Billy Goat's Gruff or whatever it might be in my atlas or my point cloud? The other thing that atlases are very good at is delivering relevancy in layers. So I can have a map of Czech Republic or the UK, and I can look at the rivers and the forests and the mountains, or I can look at the political boundaries. The point about it is the data we're providing is relevant to different people at different times in different ways. And the other thing I want to be able to do is I want to be able to collaborate. I just don't want to send people a point cloud and it just sits there like a 3D postcard. I want people to contribute to it. And more importantly, if I'm a digital twin person, what I really want to do is be able to update it, because otherwise it's just a historic document. I need to be able to collaborate and update things. So I'm going to introduce you to those people who don't know about this. There's a thing called the OpenUSD, Universal Scene Descriptors. Can I have a quick show of hands? How many people know what I'm talking about? Oh, that's great. There's only a few of you. Brilliant. Okay, so OpenUSD has been around for a few years, and anybody who follows me on LinkedIn will know I've been writing about this for about 3 or 4 years. OpenUSD was invented by Pixar to manage the digital assets in their films. So every strand of hair on the prince's head is an object. But what they need to be able to do is collaborate on those things. What happened, they gave that to the planet. And a number of companies you might have heard of, NVIDIA, Apple, Adobe, Bentley, Esri, who else? Oh, pretty well everyone, have all got together in one room. And the reason that they're doing that is because it's basically it's the HTML of 3D. If I've got a website, a web page, what it does is it aggregates information, text from here, photograph from here, photograph a SQL query for a database from there. And that's what this does. It provides us with what we call universal interoperability. Acts like a universal bridge. So you don't have to worry about having to do things in a different format anymore. It just allows all these different formats to talk to one another. It allows us to share point clouds. It allows us to share mesh models, CAD tools, real-time game engines, all sorts of different things. And the interesting thing it is, and the reason why people like NVIDIA are involved in it, is because it provides a massive scalability. Almost infinite. We're built to manage millions and millions of objects with a sort of zero latency. So it's basically a universal translator. So what we can do is we can use this in heritage or in our infrastructure projects where we're often dealing with digital silos. We have this point cloud, and we have this Revit model, and we have this IFC model. They're all different silos, but how do they all talk to one another? OpenUSD provides it and fixes this problem. It's not just a file format, it's a powerful open source framework. It's developed by Pixar really to manage all these millions of assets when you get into a film. But it can be used and is being used by lots of people to build digital twins. I'll let you read all that anyway because you got the slides later on. But the real value for me is that it allows us to provide what we call variance. And variance means I can have one file and with a very little effort, I can change it to do something else. Its core capabilities is non-destructive. I can edit, curate it, do whatever I like with it, but I'm not going to kill it. The variant sets, as I'm just going to show you in a second, allows me to do different things. So I can show a variant of something taken today, and then a variant of something that was taken 2 years ago, all in the same file format, all in the same environment without having to change it. Because the normal way you would do it is I'd have to produce a mesh model of something in one condition and a mesh model in another condition, and then upload those. But the real thing is it's allowing live collaboration as well. What does that mean? Well, for example, what I can do if in heritage or say this was a crack, photogrammetry normally likes us to use flat lighting, which is great. We get the normal universal color, or the correct color. But sometimes we want to use a thing called raking lighting, which shows the tool marks and the cracks. Now, I've got normally to deliver 2 different photogrammetry models of this, but with USDs, I don't have to do that anymore. Okay. It's one asset and many, many stories. The variant set allows us to look and compare things, and there's just thousands of use cases that we can talk about. The efficiency really is I don't need to have 5 different files. Now, you're probably wondering, how is this going to impact me? I would suggest that this time next year, when you're having a conference, everyone's going to be talking about OpenUSD as a way that we can share information. So you're going to need to learn some new languages if you don't, some new words if you don't know this. Introducing LIVRPS. Now the good news for you is this is pronounced LIVRPS. Okay, so you're able to share this with your kids and go, I've been working on LIVRPS today, and they'll be able to laugh. Okay, because you're not swearing, but it is pronounced LIVRPS. And there's some things you need to remember, or some words you need to know. Prims. This is like the fundamental objects that we're working with. Layers, so we can deliver information in different layers. Remember the atlas and the physical map and the political map? Allowing us to deliver in layers, allow us to deliver relevancy to the user. If I come into a building as a fireman, I don't want to know what the carpet is. I do want to know where the safety shut-off valve is. That's relevancy. That's about putting our data to use. We also have a stage, and the stage isn't like this, but a stage is the platform where we can bring different things in. Change things, change configurations. And it's not really much surprise when you think about the digital twin industry, largely dominated by NVIDIA. Their platform, Omniverse, is powered by USD, built on a stage. And the other thing is it allows for payload. It allows us what we call lazy loading. We don't have to worry too much about the performance. We're only loading what's visible. And this comes into one of the big problems we have as a sector. If I want to do a big digital scan of a building, I've got to go and upload all the mesh model. With USDs, you don't. You only upload what you need in different formats. So it could be, for example, I've got a building but a plant room. I could have it in one level, but then I could have the plant room at another level of definition, and I can have the pump or whatever it is, the critical piece of machinery in a metrology level, down to a millimeter or less, and simulate what's going on, all in the same environment. Okay, so we're actually using this on a thing called the Shackleton Project. So I've been working on like 6.5 continents this year in different projects, and the reason it's 6.5 is because it's there. It's right down the bottom. This is part of it's part of the British Antarctic Survey, so I'm claiming Antarctic continent for the work. The story is from Shackleton the explorer. His boat sank and he navigated and saved his people and was rescued by this whaling station. And we're constructing a 3D model of this because, to be honest, the only people there are penguins. And this was great. For the first risk assessment I've ever done, we had to put elephant seals in here, which are massive, great big things. We're not allowed to camp on there because they roll over. This whole place is not very accessible, but some people, lovely Norwegian timber people and carpenters, have refurbished what's called the villa, which is where Shackleton came over the mountains, knocked on the door, opened it, said, "My name's Shackleton," and everybody burst into tears because they thought he was dead. But this is what we're trying to do. But we're trying to build this using USDs, and the reason we're doing that. Okay, so so this is my crew who are surveying down there. We're using photogrammetry, we're using mobile scanner, and the reason I like this is because all this area is contaminated with asbestos. Okay, so the tourists can't go there, but we need to share this and story, and we're actually working for a film production crew to develop a 3D model of this. But that's not the interesting thing. The interesting thing is that we're able to use USDs. So we are going out and scanning. So we built the model of the villa, but what was in it at that time? So what we're doing is going around different museums and scanning the artifacts, converting them into USDs, and then we're going to upload all that, and people can view it. Okay, so I'm just going to tell you, so this picture here, so what we're able to do with USDs is the Stromness Villa on this one here is we can actually, we've got it scanned in the restored state, but we'll be able to skim back to what it was in the derelict state, but we'll also be able to add different bits in there, like the bath and the table and the chair, which have been scattered to the four winds in different museums all over the place. And I'm working on another project, and this is, hopefully this will work. Yeah, it will. This is from Mike Devers, who's done this. This is a Gaussian splat, and this is just to show the sort of thing we want to be able to do. This is, Thomas Brassey was one of the most unfamous engineers. At one point in the world, he made a 20th, or 1 in 20 of all the miles of railway line that were built. No one knows about him. But using AI, Mike's been able to actually show us what it was like. And this is from a Gaussian splat with a bit of AI. Visa Skies, are you in? I think they probably use you for that. But this is about engagement. This is about telling a story. It's not just about a plant. It's not just about that. That's what this is outside my hometown in Chester. And interestingly, he was a land surveyor who was born and built his factory 200 yards from me. Okay, it's about storytelling, I think. What we do is all about storytelling. Is it storytelling about the history, or storytelling about the history, the maintenance of my plant, my oil platform, my hospital, my building? USDs provide us with a tool that takes us to another level of engagement and collaboration. A project I was working on last year, if you want to, and this is to do with another aspect of what we call digital asset management. If you want to take a photograph of that, you will be able to see this temple in this room. Okay? Don't do it, you can do it later on, or take it. Just take a photograph. Don't do it right now, because I'm talking, but I know you get all excited. But this is a Gaussian, this is a model which is a USD version, I call it USD-Z, and is managed by a digital asset management software called Ventana. And what the Met have done is they've taken 100 objects and they've scanned them to put them out there. And the great thing about the Met is they've been taking photographs for 120 years. They know how to light things. I just worked with them last February, I think January, February, helping them get the photogrammetry sorted. But also, you can have a look at digital asset management. If you want to take a photograph of that, that's going to bring a bit of industrial plant into the room, which you will be able to navigate. Again, it's an example of a USD. So I'd like to thank you for that bit, but then I've got to thank you for you guys. So I've been writing a book over the last year about digital twins. And the issue I've got there really is, if you want to write a book about digital twins, by the time the ink is dry, it's out of date. Things are moving on ever so quickly. So this is a book, it's around 100 pages of what I think, my views, my personal view. If you want to disagree with it, absolutely fine. But it's about how human beings are going to relate to the 3D world. How do we get this? How do we make it useful? How do we collaborate with it? Now, if you want a copy of this, there's a simple thing. Just send me your email, hit me up, and I'll send you a copy of it. But no, this is going to be a subscription thing, okay? I'm not going to charge you for it. But I'm going to have to add chapter after chapter and bring this up. And every month or so, there's going to be a new chapter. But if you'd like to go on there, that will take you to a page where you can get all sorts of information about what it is that I do. I try and share what I know about photogrammetry. I think I'm about to do about 150 tips on photogrammetry on LinkedIn now. I've got loads more. I'm going to bore you for years with that. Okay? But also, on that page, you'll be able to link to my blog site where I've got over 100 articles about photogrammetry and stuff. But I'd really like your impressions of what I've written here. This is about how we move and take this technology and make it much, much bigger than the CAD delivery or the GIS pilot or whatever it is. We are on the verge of a massive, massive explosion in our technology. And I don't think people realize just how big it is. Now, I think I might be the oldest person in the room. And I'm really excited. I'm never going to retire because this stuff is so sexy. All right. So that's it for me. I'm here till Thursday evening if you want to hit me up. Oh, and also the other thing is The Shackleton Project, I'm not allowed to show it, but if you buy me a beer, I've got it on my phone. All right? So I think I'm going to get very drunk later on. So that's it for me. I hope to see you later on in the bar and talk about all things to do with digital capture and sharing and taking this off. This is such an exciting time for this industry. I look forward to sharing the journey with you.
Ladies and gentlemen, Barry Bassnett. Thank you so much, Barry. A couple of questions, one or two. We still have time.
Okay. Well.
USDs, they have existed for quite a few years, actually, now. So why do you think they haven't been embraced as the universal file format yet?
Largely, there's a number of reasons. I think most people wanted to protect their own intellectual property, which is entirely unbelievable. But what you've got now is you've got all the big players in the room. FOMO, fear of missing out. If they are able to work in USDs, basically they're going to be extinct, in my view. Now, that might seem a bit dramatic to say, but in all my years, and there's a few, since I've been doing this since the Jurassic period, this is the first time I've seen all these people in the room at the same time talking. And the reason it's working is because of NVIDIA and Omniverse. It is powered by USD, and everybody wants a piece of that action. Apple, Google, everyone.
Let's give it up for Barry one more time, and let's give him a beer. It's going to be a fun night.